Lesson 4.1, Factors in Prime Factorization. Prime number is a whole number greater than 1 whose only positive factors are 1 and itself. An example of a prime number is 2, which is actually the only even prime number, 3, 7, 9, 11, 13, and so on. Again, that means that the only thing that divides by these numbers is 1 and itself. A composite number is a whole number greater than 1 that has positive factors other than 1 in itself. This could be like 4, 6, 8, 10, 12, and it's not just even numbers. It could also be like 33, okay, and so on. Okay. And again, I did miss 5 up here, but again, it's not like you have to go in order. Prime numbers are a whole bunch of them, just as long as they're divided by 1 in itself. Composite numbers, let's say for example 4, that can divide by 2 and 2, and 4 and 1. Where 6 can be 2 and 3, or 1 and 6. Okay, there's more than just 1 in itself. Prime factorization is writing a number as a product of prime numbers. I will show you how to find prime factorization later in this section. To find prime factorization, we use a factor tree. It's a diagram that's used to write the prime factorization of a number. A monomial is a number, a variable, or a product of a number and one or more variables. For example, a number like 4, or 16, or 125, or monomials. It can also be variables like x, y, a, or a product, which means multiplication, of a product of a number and one or more variables. So 4 times x, 16 times y, or 125 times x times y. These are all monomials. Or even just x times y, or a times b. You can even have a times b squared, because that's 2 b's. A times b times b. These are all monomials. What is not a monomial is when you start adding, basically adding monomials together, like 4 plus 2x. This whole thing is not a monomial. 4 is a monomial, 2x is a monomial, but when you start adding or subtracting them together, it is not a monomial. Division, though, is a monomial. Okay? This is a monomial, because technically division is 1/4 times x. So that is a monomial. Example 1. A band with 48 members is arranged into a rectangular formation with the same number of members in each row. There should be at least 2 rows with at least 3 members in each row. So you need to find the possible formations by finding the factor of 48. You can write 48 as a product of 2 numbers in these possible ways. 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. This is what you would call listing the factors. Okay, when you use the list method to find the factors, you take 1 and then go down to the end, which is 48. And then you go 2 and 24, 3 times 16, 4 and 12, 6 and 8, until there's nothing left in between that's a factor of 48. These are the possible formations then. You can have 2 rows with 24 members, 3 rows with 16 members, and 4 rows with 12 members. You could have 6 rows with 8 members, or 8 rows with 6 members, 12 rows with 4 members, or 16 rows with 3 members. Remember that the 1 times 48 won't work because you want at least 2 rows with 3 members. So there are 1, 2, 3, 4, 5, 6, 7 possible rectangular formations. For numbers 1 through 4, you need to write all the factors of the numbers. If you know how to do it, go ahead and pause the video. Otherwise, I will show you number 1. 30 is divisible by 1 and 30. 2 and 15 make 30. 3 and 10. And 5 and 6. You can see there's not going to be anything else because I kind of keep going in until I'm very close to the other numbers. You can see there's nothing between 5 and 6. Or at least nothing that can be divided into 30. These are the factors. At this point, pause the video and try 2, 3, and 4 by yourself. For number 2, we have 1 and 31. And that's it. We would actually call this prime, and we'll get to that then, because the only thing that's divisible by 31 is 1 in itself. So that is prime. Number 3, we have 1 and 45. 2 doesn't work. 3 and 15. 4 doesn't work. 5 and 9. And that's it. Number 4, 1 and 51. And go through, do some guessing and checking. 2 doesn't work. Does 3 work? And you can divide. That would be 1, 3. 3 goes into 21 7 times. So 3 and 17 work. Or 5 doesn't work because it doesn't end in a 5. So 1, 3, 17, and 51. Do not just give up if you think it's going to be prime. There are sometimes more numbers than you might think. We're going to identify the numbers as either prime or a composite. So for 18, well, 18 divides by 2 because it's an even number. If it's an even number at the end, it's divisible by 2. So it is. We can list out the factors, but it is definitely prime, composite. 49. Now it's not even, so the only thing, I can't divide by 2, but is there anything else that can divide by 1? 49. We have 1 and 49, and you should have thought of 7. This is not prime, it's composite, because 7 and 7 make 49. 58 ends in an 8, it's even, so it's definitely composite, because you have 2 and 29. 67, the only factors are 1 and 67, so it's prime. 131, may need to do some guessing and checking. No, that's not going to work. It doesn't end into 5, so it's not divisible by 5. The only factors are 1 and 131, so this is prime. For F, 165, it ends in a 5, which means it's divisible by 5. This is composite. For example 3, we're going to write the prime factorization of 540. To write the prime factorization, you're going to use factor trees. Okay? It's the only way you can find the prime factorization. Your factor tree may look different than your neighbor's factor tree because it depends which 2 numbers you choose to divide into 540. So I'm going to show you 2 ways. This is just 2 examples of how to find this example 1 and example 2. 2 ways to find the same prime factorization. No matter how you go about making your factor tree, you're going to get the same prime factorization. For the example 1, you can see that we took 540, which is 27 times 20. 27 is 9 times 3. And then 9 is 3 times 3. 3 is prime, so I can circle that, or I can continue to bring it down. 20 is 4 and 5. 5 is prime. 4 is 2 and 2, so 2's a prime. Again, you can just circle your prime numbers or continue to bring them down so they're all in one line. Example 2, we went 5 times 108. 5 is prime. Again, we can just bring it down too. Kind of make a nice full tree that way. 108 is 9 and 12. 12 is 3 and 4. 3 is prime. Again, we will bring it down later then. Where 4 is 2 and 2. 9 is 3 times 3, which will just bring it down just so it's all in one line. For example 1, I want to put it in order. I want to put the primes in order from least to greatest. So I have 2 2's, 3 3's, and a 5. For example 2, I have 2 2's. If you need to cross them off, I should do it. A 3, 3 3's actually, and a 5. You can see that's the same for each of them. To finalize your prime factorization, we want to use exponents. So there were 2 2's, so we say 2 squared. 3 3's is 3 cubed, or 3 to the third power, and 5. This is my final prime factorization. Again, the prime factorization has to use exponents. For examples 5 through 8, all you're doing is telling me whether it's prime or composite. Remember, some simple things is to look to see if it divides by 2. Okay? That means if it ends in an even number. If it ends in a 5, it divides by 5. If it ends in a 0, that means it divides by 10 and 5. Number 5 is an even number, so we know that it's going to be composite. The only even number that is prime is 2. You can see the factor tree. We have 2 squared times 7. 61, the only thing that divides into it is 1 and 61, so it's prime. 7 is even, so we can use our factor tree. 2 cubed times 3 squared. And again, you can do 8 and 9, which is 4 and 2, 2 and 2, and 3 and 3. 8 is 10 and 60, 5 and 2, 6 and 10, 2 and 5 are prime, 2 and 3 are prime, 10 is 5 and 2. So you have 2 cubed, 3 times 5 squared. Remember to put the multiplication in your prime factorization as well as the exponents. For example 4, we're going to factor a monomial. To factor a monomial, it's actually expanding the monomial. So you make a factor tree of your number. You can see we have 3 2's and a 3. Again, multiplication in between there. An x and 3 y's. We are going to expand that exponent of 3 y's. This is factoring the monomial. Try 9 through 12. For number 9, it's already factored. Just put the multiplication in between. 20 becomes 2 times 2 times 5, and then 3 t's. Remember, multiplication in between. And we are not using exponents. No exponents here. 36 is 2 times 2 times 3 times 3, and there's 2 x's, we expand those out, and 4 y's. 12, 56, and again, to get the 56, factor it out using a factor tree. You get 2 times 2 times 2 times 7 times p times p times p times q. That is called factoring the monomial.